Hello everyone, today we will be starting with the concept rate of change of quantities. As I told you, this concept is important for 5 mark. In the part D, 43rd question will be from this concept. Okay, already I have written the question here. First you have to read the question carefully. See, find the rate of change of the area of a circle. So you are finding the rate of change of the area of a circle per second with respect to its radius r when r is equal to 5. Since this is a verbal problem, you have to write step by step, okay? And it's a 5 mark also, so you have to better you write the step by step. First we'll write the area of a circle. First, what I do? Area of a circle with radius r. Okay, area of a circle with radius r. What is the area of a circle with radius r? It is given by a, right? Area of a circle is given by a is equal to pi r square. Area of a circle a is equal to pi r square. Since it is an area, we can write this one as a centimeter square. Now next what you have to write? The rate of change of, is it clear? With respect to the radius, right? The rate of change of area of a circle, with respect to radius r is given by dA, right? Area of a circle with respect to the radius r, dA by dr. So this will be equal to now d by dr of, what is a? It is pi r square. I substitute pi r square. Is it clear? Now you have to differentiate pi r square with respect to r. Now this is equal to, here pi is a constant, right? So pi we write as it is, and derivative of r square with respect to r will be 2r. Is it clear? We got dA by dr is equal to 2 pi r. Now one more condition is given. When the radius r is equal to 5, substitute r is equal to 5. When r is equal to 5, what will be the value? Now dA by area of a circle with respect to the radius, right? Rate of change of area of a circle with respect to the radius r is given by, if I substitute r is equal to 5, so this is now 5 into 2 will be 10 pi. Is it clear? 10 pi. Finally you have to write the unit. Here area of a circle is there and here radius is there. We are finding per second. So unit for this one, centimeter square per second. Is it clear? So the rate of change of area of a circle with respect to the radius is given by 10 by centimeter square per second. And finally you have to write, therefore the area of a circle changing at the rate r is given by, what is that? 10 pi centimeter square per second. So this should be the final answer. The area of a circle changing at the rate, at r is given by 10 pi centimeter square per second. Till here you have tried. See the next problem. First work is you have to read the question carefully. Okay, let us read it. The volume of a cube. So cube is given. Volume of a cube is increasing at the rate of 9 cubic centimeters per second. So the rate of change of volume is given with respect to the time. How fast the surface area. So surface area is increasing. You have to find how fast the surface area increasing when the length of an edge is 10 centimeters. Is it clear? First the cube is given. Let us consider the edge of a cube. That is, I'll consider, let x be the edge of a cube. Okay. So we have considered the x be the edge of a cube. Now two more things are given. It is, you have to find the surface area as well as volume is given, right? Volume and surface area. What is the volume representation? Let V, right? It is a capital V. Let V be the volume and surface area is represented by capital S, and S be the surface area. Is it clear? Let S be the surface area of a cube. Now, what is the volume of a cube is given? It is x cube. Here the x is the edge. So the volume of a cube is given by V is equal to x cube. In the previous session, I had given all the formulas, right? V is equal to x cube and surface area of a cube is given by S is equal to 6x square. Okay, this is the first thing you have to write. Now we'll see this one. The volume of a cube is increasing at the rate of 9 cubic centimeters per second. I mean dV by volume of a cube is increasing with respect to the second time, and it is given that dV by dt, right? dV by dt is equal to 9 centimeters per second, right? Centimeter, 9 cubic centimeters. So this will be 9 cubic centimeter per second. So this is given. Now dV by dt. So we'll substitute the value of V. V is now x cube. We'll substitute it. So 9 is equal to, I can write dV by, so capital V, dV by dt. So this is equal to d by dt of, what is V? V, volume of a cube is given by x cube. We'll substitute that. So this is now x cube. Now you have to differentiate this derivative of x cube with respect to t. Is it clear? We are differentiating only this one, not this one. This is given by d by dt of x cube is given by derivative of x cube will be 3x square. But remember one thing, you are differentiating the function x with respect to t. So we need to differentiate x. So derivative of x with respect to t will be now dx by dt. Is it clear? So we got 9 is equal to 3x square dx by dt. Now we will cancel this 3 and 3. By this we got dx by dt is equal to, so clear, dx by dt is equal to 3 by x square. Let it be. Now we will see the surface area. Right? How fast the surface area is increasing. So we need to find the surface area with respect to the time. We will consider that ds by dt is equal to d by dt of, what is the value of s? Surface area is given by 6x square. So we will substitute that. So this is equal to 6x square. Now you have to differentiate this with respect to t. So this will be now 6 into derivative of x square with respect to t will be 2x. Not only this much. Now you have to differentiate x with respect to t. So derivative of x with respect to t will be dx by dt. Is it clear? So by this what we got, ds by dt is equal to 6 into 2 will be 12x, and here we have the value of dx by dt. It is 3 by x square, right? We will substitute that 3 divided by x square. I will consider this as 1, okay? This is from 1, is it clear? From 1 we have substituted the value of dx by dt. Now here 1x and x will get cancelled. So we got dx by dt is equal to 36 divided by x. Right? Now one more thing is given. How fast the surface area is increasing when the length of an edge is 10 centimeters. I mean length of the edge means that is the value of x is equal to 10 is given. Right? We will substitute that when x is equal to 10. Sorry, this should be s. Okay. When x is equal to 10, what will be the value? Now ds by dt is equal to 36 divided by 10. So this is equal to 36 divided by 10 will be 3.6. So clear? 3.6. Then you have to write the unit. Unit is compulsory. So surface area divided by time. This is given in the form of centimeters. So this will be now 3.6 centimeter square per second. Is it clear? So this is the answer. 3.6 centimeter square per second. Finally you have to write the surface area increases in the rate of 3.6 centimeter square per second. A stone is dropped into a quick lake and waves move in a circles at a speed of 4 cm per second. Okay, at the instant when the radius of a circular wave, suppose the radius of a circular wave is 10 cm, how fast is the enclosed area is increasing? So here you have to find out how fast the enclosed area of a circle we'll write the what is the area of a circle. Okay, area of a, this is a problem based on a circle, so we'll write the area of a circle is, representation is A is equal to pi r square. Now what we have to find? See this one, it is in the speed 4 centimeter per second. I mean it is based on the time, right? So this one will be, now we can write the rate of change of a area of a circle with respect to the time t. Is it clear? dA by dt. In the previous circle problem there it was with respect to the radius, but here it is with respect to the time. So dA by dt is equal to d by dt of what is A? A is now pi r square. Now we need to differentiate this function with respect to t. So this is equal to pi into derivative of r square will be 2r, but you are differentiating the function r with respect to t. So this will be now dr by dt. Is it clear? Now to find the value of dA by dt, we need the value of dr by dt. Already it is given here. See, the waves moves in a circles at a speed of 4 centimeter per second. 4 centimeter per second, obviously it will be a dr by dt, radius with respect to the time. So given that, what is given? Given dr by dt is equal to 4 centimeter per second. Now just we substitute that value here. So by this we can write dA by dt. Is it clear? This is the area of a circle with respect to the time. So dA by dt is equal to 2 pi r into dr by dt will be now 4 centimeter per second. So we substitute this. This is equal to 4. So this is equal to 8 pi r. Is it clear? So dA by dt is equal to 8 pi r. One more thing is given, right? We have to find when the radius of the circular wave is 10 centimeter. I mean the value of r is given, right? The radius is given when r is equal to 10. What will be the value? If it is r is equal to 10, then it is dA by dt is equal to 8 pi into the value of r is 10. So this is equal to 10 into 8 will be 80 pi. Is it clear? So this is area with respect to time. So area will be, now this is centimeter square per second. Therefore finally you have write thus the what is given. See, finally you have write thus the enclosed area is increasing. Thus the enclosed area of a circle, okay, enclosed area of a circle increasing, enclosed area of a circle increasing at the rate, what is the rate here? 80 pi centimeter square, 80 pi centimeter square per second. So this will be the final answer. See this problem, this was asked in the 2019 final paper. Okay, we'll see the question. The length x of a rectangle. So this problem is based on the rectangle. The length is given. X of a rectangle is decreasing at the rate of 3 centimeter per minute. I mean the length of a rectangle is decreasing with respect to the time, and the width y is the width of a rectangle is increasing at the rate of 2 centimeter per minute. I mean width is increasing with respect to the time. Now when x is equal to 10 centimeter and y is equal to 6 centimeter, you have to find the rate of change of the perimeter of a rectangle and the area of a rectangle. I hope you understood the question. Now we will start. What is given? Already it is given that the length is x and the width is y. We will write this. Since length x is increasing, length x is decreasing, right? So length x is decreasing. Since the length x is decreasing, okay, and width y is increasing. Width y is increasing. Width y is increasing with respect to the time, because it is given by 3 centimeter per minute, right? With respect to the time, it is given that by this we can write, see, that is dx by dt, the length of a rate of change of a length of a rectangle with respect to time is given by, since it is decreasing we have to take the negative side. Is it clear? If it is decreasing we have to take the negative side, if it is increasing it will be a positive. So decreasing, so this is now minus 3 centimeter per minute. Okay, that is the change in the length. Now change in the width, that is dy by dt, right? Dy by dt, it is increasing, right? Increasing at the rate of 2 centimeter per minute. So this will be now 2 centimeter per minute. I hope you understood this one. This is rate of change of a length with respect to time is decreasing, so it is negative. Rate of change of a y is increasing with respect to time, so it will be positive. Now what you have is to find the perimeter of a rectangle with respect to time. For that, first we will write perimeter of a rectangle. What is the representation for perimeter? It will be P, right? It is given by P is equal to 2 into x plus y. Now you have to find the rate of change of P with respect to time. So we will differentiate the function with respect to t. Okay. So derivative of P with respect to t will be now dP by dt is equal to 2 is constant as it is. Derivative of x with respect to t will be now dx by dt plus derivative of y with respect to t will be dy by dt. Anyway, we have the value of dx by dt and dy by dt. We'll substitute here. So this is now 2 into dx by dt is, here it is minus 3. So this is now minus 3 plus dy by dt will be plus 2. So this is equal to minus 3 plus 2, minus 1 into 2 is minus 2. Minus 2 perimeter with respect to time. So obviously it will be centimeter per minute. Time is given in the form of minute, right? Centimeter per minute. Is it clear? So the perimeter of a rectangle decreasing with respect to the time t. Now we will find second question is, you have to find the area of a rectangle. First we will write the area of a rectangle. What is the area of a rectangle is given by, it is A is equal to x into y. Right? Again we will differentiate with respect to the time t, because we need to find the rate of change of area with respect to time. So this will be now, if you differentiate with respect to time, dA by dt is equal to, anyway there you need to apply the product rule, x into y will be derivative of y with respect to t will be dy by dt plus y into derivative of x with respect to t will be dx by dt. Anyway, we have the value of dy by dt and dx by dt, and one more thing, the value of x and y is also given. We'll substitute this one. The value of x is given as 10. So this is 10 into dy by dt will be 2 plus the value of y is given as 6 and dx by dt is minus 3. Why it is? Since it is given x is equal to 10 and y is equal to 6. So simplify, 10 into 2 will be 20, 20 minus 18 will be plus 2. Here the area of a rate of change of area of a rectangle with respect to time. So area will be now centimeter square per time is given in the form of minute. So centimeter square per minute. So this is the answer. Is it clear? This is the rate of change of perimeter of a rectangle with respect to time. This is the rate of change of area of a rectangle with